All right, guys. So, still on this charge, let's consider this question on the board. It says a 400 millimeter diameter pipe reduces to a diameter of 200 millimeter, which expands to 250 millimeter and then reduces to 150 millimeter, which finally expands to 300 millimeter. If the velocity of flow in the 250 millimeter pipe is 2.8 meters per second, question says what is the discharge in the pipeline and what are the average velocity in the other pipes. Okay, so this is a little bit different from the previous question we solved. Let's try to plot out the diagram and see. First of all, we have a 400 millimeter diameter pipe. So let's take this to be 400 millimeter. Okay, reduces to a diameter of 200 millimeter. So this reduces, okay, this reduces to a 200 millimeter diameter. So let's call this 200 millimeter diameter. Okay, now which expands to a 250 millimeter diameter. So it expands again to a 250 millimeter. So let's simply take here to be 250 millimeter. Okay, and then reduces to 150 millimeter. There's another reduction. So we have this. Okay, so take this to be 150 millimeter. Okay, which finally expands to 300 millimeter. So there's a final expansion. So you call this 300. All right, so you have this. So this is the first pipe. D1 was given as 400 millimeter. Okay, second pipe was given as 200 millimeter. So you have diameter in this pipe to simply be 200 millimeter. Okay, this was given as 250 millimeter. Okay, yes, we have 250 millimeter. And this was given as 150 millimeter, 150 millimeter, and finally 300 millimeter. Okay, you have this to be 300 millimeter. So that represents the whole information given to us. So let's call this pipe 1. Let's call this pipe 2. Let's call this pipe 3. Let's call this pipe 4. And let's call this pipe 5. Okay. Now the question says if the velocity of flow in the 250 millimeter pipe is 2.8 meters per second. So 250 millimeter pipe is the third pipe. So V3 is already given as 2.8 meters per second. So we don't know V2, we have to find this. We don't know V1, we also have to find this. We don't know V4, we have to find this. And V5 also unknown, we are asked to find it. All right, so first question says, what is the discharge in the pipeline? Now take notes, this is just a series or a linear pipe. You have this pipe to just be what? Linear. Unlike in the previous question we solved, in the previous question we had a single pipe which branched into two different pipes. So it is very fair to say that discharge coming through here is Q1, different fluid flows through this pipe. So discharge here is Q2 and different one flow here, discharge here is Q3. You have this, but in this case, you just have a single pipe. So which means the same flow rate goes throughout the pipe. The same discharge goes through the pipe. Same discharge and same discharge. So this simply means that okay, so since this pipe is a linear pipe, therefore the continuity equation in this case now the continuity equation in this case becomes Q1 equals Q2 equals Q3 equals Q4 equals Q5 and so on. So this becomes the continuity equation simply because the pipe is actually what? A linear pipe. And of course, the flow rate intensity becomes the same. It is not branched, it's a linear pipe. So you have this. All right, so the first question says we should find the discharge in the pipeline, and we are given velocity of pipe 3 to be equal to 2.8 meters per second. And of course, we know the diameter of pipe 3, which means you can find the area of that pipe. Okay. All right. So having known the velocity of pipe 3 and diameter of pipe 3, we can simply find discharge Q3, discharge in pipe 3, and that's simply equal to A3 multiplied by V3, which is area of portion 3 multiplied by velocity of that portion. And of course, we know that area of portion 3 is simply pi diameter of portion 3 all squared all over 4. You have this, okay? Where okay, where diameter of portion 3 was given in the equation as 250 millimeter. That's diameter of pipe 3 was given as 250 millimeter. So this is equal to 250 by 10 to the power of minus 3 in meters, converting it to meters, and that's about 0.25 in meters. So you have this for the diameter of that portion. So if you know this, we can now compute the area of portion 3. This implies that area of pipe 3 is now equal to, we said pi, and pi is 3.142, okay, multiplied by diameter of that portion squared, and diameter of pipe 3 was given as 0.25. So we have 0.25 all squared divided by 4, okay? So let's quickly obtain 3.142 multiplied 0.25 squared. That gives us 0.196375 divided by 4. So this implies that area of pipe 3 is now equal to 0.0491 meter squared. Okay, so this becomes the area of portion 3. Therefore, discharge in pipe 3 Q3 is now equal to, we said the discharge is simply area of portion 3 multiplied by velocity and that portion, and the velocity at the portion is 2.8 meter per second. Therefore, discharge at that portion becomes area, which is 0.0491 multiplies velocity, which is 2.8. So this implies that discharge Q3 is now equal to 0.1375 in meter cube per second. So this becomes discharge in pipe 3, but not forgetting from continuity equation that Q1 equals Q2 equals Q3 equals Q4 equals Q5, and that's equal to 0.1375 meter cube per second. So this becomes the discharge through the pipeline. So the first question is solved. Determine the discharge in the pipeline. So we have that. Next question says, what are the average velocity? What are the average velocities in the other pipes? So it's very simple, since we know that Q1 is equal to Q2 equal to Q3. So this simply means now, this whole equation simply means that Q3 is actually equal to what? Q1. It also means Q3 is equal to Q2. Also, Q3 is equal to Q4. And finally, Q3 is equal to Q5. So you simply have this whole equation. This is what it actually means, that the discharges throughout the pipe are what? The same. So Q1 equals Q2, Q2 equals Q3, Q3 equals, and so on and so on. So here we have Q3 equals Q1, Q3 equals Q2, and so on and so forth. All right, so let's break down the whole analysis over here. I think I can wipe here now. Okay, so from this given condition now, Q3 from Q3 equals Q1, we know that Q1 itself is equal to A1 times V1. We know this. So all we need to do is simply what? Obtain the area of pipe 1, equate that to this. So if Q1 is A1 V1, this simply implies that Q3 itself becomes now, in place of Q1, you simply have A1 V1, and therefore you can find V1, which is the speed or velocity at pipe 1, to be equal to Q3 all over A1. Okay, so we know Q3. All we need to do is simply what? Find the area of portion 1. Okay, where the area of pipe 1, where A1 is simply equal to pi times diameter 1 all squared divided by 4. This is now equal to pi is constant, 3.142 multiplied by diameter of pipe 1 was given as 400 millimeter, and of course 400 millimeter is something as 400 by 10 to the power of minus 3 a meter, which is approximately 0.4 meters, which is approximately 0.4 meters. Therefore, pi D1 becomes 0.4 all squared divided by 4. Okay. All right. So A1 becomes equal to, so we can obtain now 3.142 multiplied 0.4 squared. Let's do that and see. That gives us 0.15272 divided by 4. So this simply implies that area of pipe 1 is equal to 0.15272 divided by 4. That gives us 0.12568 meter squared. So if you obtain this for the area of pipe 1, then we can now compute velocity in pipe 1. Therefore, velocity V1, okay, velocity in pipe 1, we said is simply discharge at pipe 3, and Q3 was given to us, we obtained the value here as 0.1375 meter cube per second. So in place of Q3, we have 0.1375 all over area of portion 1, 0.12568. This simply implies that velocity in pipe 1, V1, is now equal to 0.1375 divided 0.12568. You have 1.09 meters per second. So this becomes the speed of flow in pipe 1. Next is to find velocity in pipe 2. Okay, we can do that over here. Let me wipe here. Okay, so to find the velocity in pipe 2, we have also said that Q3, okay, is equal to Q2 from continuity equation. So this simply implies, okay, where Q2 itself is simply area of pipe 2 multiplied by speed of pipe 2. So this can actually mean that Q3 is equal to, in place of Q2, this means that Q3 is now equal to, in place of Q2, we simply have A2 V2. So this is simply A2 V2. So we'll make V2 subject to the formula, what we're looking for. Therefore, velocity of pipe 2 is simply what? Q3 all over A2. Okay, where A2 is simply equal to pi times diameter of pipe 2 all squared divided by 4. And we know diameter of pipe 2, D2, was given in the question as 200 millimeter, which is 200 by 10 to the power of minus 3 in meters. And this is approximately 0.2 meters. So diameter of pipe 2 is 0.2 meters. Therefore, area of portion 2 becomes pi is constant, 3.142 multiplied by diameter of that segment, which is 0.2, all squared, divided by 4. Now, this is equal to, so let's obtain 3.142 multiplies 0.2 all squared. That gives us 0.12568 all over 4. So 0.12568 divided by 4 gives us, this implies that A2 is equal to 0.03142 in meter squared. So area of portion 2 is given as 0.03142 a meter squared. Having known that, we simply substitute into this given equation to obtain the value of velocity at that segment. Okay. All right. So V2, velocity at pipe 2, is now equal to discharge at pipe 3, Q3 all over A2, and Q3 is 0.1375 divided by area of that pipe 0.03142, 0.03142. So this implies that velocity at pipe 2 is now equal to 0.1375 divided 0.03142. You have that to be 4.38 meters per second. So this becomes the speed of flow in pipe 2. Also, from continuity equation, we also said Q3 is equal to Q4, okay, where Q4 itself is simply A4 multiplied by V4. So this simply means that Q3 is equal to, in place of Q4, we have A4 multiplied by V4. Therefore, we can make V4 subject, which is speed in pipe 4, and that's simply equal to Q3 all over area of pipe 4. So all we need to do now is find area of pipe 4. The diameter of pipe 4 was given as 150 millimeter. D4 was given as 150 millimeter, which is simply 150 by 10 to the power of minus 3 in meters. And this will simply give us approximately 0.15 meters. Okay. Therefore, area of pipe 4 is pi, diameter of 4 all squared divided by 4, and that's equal to, pi is constant value, 3.142 multiplies, diameter was given as simply 0.15 all squared all over 4. So all we need to do now is, let's obtain 3.142 multiply 0.15 squared. That gives us 0.070695 all over 4. Okay, this now implies that A4 is now equal to 0.070695 divided by 4. This gives us 0.0177 meter squared. So this becomes the area of pipe 4. And if we know this, we can now obtain the velocity of pipe 4 from this equation. V4 becomes Q3 all over A4. Therefore, V4 equals Q3 over A4, and Q3 was given as 0.1375 divides A4 given as 0.0177. This implies that the speed of flow in pipe 4 is simply equal to 0.1375 divided 0.0177. And that gives us 7.78 meters per second. So this becomes the answer of the velocity in pipe 4. Finally, we obtain velocity in pipe 5. Okay. Alright, so from continuity equation again, we obtain Q3 to be equal to Q5. Alright, so without much calculations, we also obtain that V5 from everything we've been doing here is simply going to be Q3, okay, all over A5. So all we need to do now is to obtain A5. A5 itself is simply pi, diameter of pipe 5 all squared divided by 4. This is now equal to, not forgetting, diameter of pipe 5 was given as 300 millimeter. Okay, so we can always convert this diameter to be 0.3 in meters, of course. So you have this to be, pi is constant, 3.142 multiplied by diameter is 0.3 all squared all over 4. So let's obtain 3.142 multiplied 0.3 squared. That gives us 0.28278 all over 4. So this implies that area of pipe 5 is equal to 0.28278 divided by 5. That gives us 0.07069 in meter squared. Having found this, um, okay, we can now obtain V5. This now implies that velocity of pipe 5 is now equal to Q3, which remains 0.1375 all over A5, 0.070695. So this simply implies that the speed in pipe 5 is simply equal to 0.1375 divided 0.070695. We have 1.94 meters per second. So these are the speeds or the velocities in each of the pipes. So let's also consider these values of velocity. Pipe 1 has a diameter of 400 millimeter. Look at the speed. The speed is a very small speed, 1.09 meter per second. But then the smallest diameter pipe here is the 150 millimeter diameter pipe, which is simply pipe 4. And we obtain velocity of pipe 4 to be what? 7.78 meters per second. And I think that is the highest velocity. Yes, it is the highest speed of flow in any of these pipes. So like what I've told you before, the higher the diameter of the pipe, the smaller the speed of flow. But the smaller the diameter of the pipe, the higher the speed of flow in the pipe. Okay, all right, guys. So that's it for that question. I hope you find this question very interesting and helpful. Please, if you do, I would like to get your thoughts in the comment section. And of course, if you have any questions at all, you can do same in the comment section or hit me up on WhatsApp, and I promise to respond to all your questions. If you're new to the channel, please do well to also subscribe to the channel, and of course, share this channel to your friends for more subscribers. I will see you in the next videos. Thanks and cheers.